In this lesson, we will cover lesson number 27, which talks about alternating current. The abbreviation for alternating current is AC. Okay, AC is the abbreviation for alternating current. This means that the direction of the current flows in a circuit is constantly reversed back and forth. Please know the definition of alternating current. Alternating current means that the direction the current flows in a circuit is constantly reversed back and forth. This is used because the voltage can easily be stepped up or stepped down. Step up, it means the voltage can be increased. Step down, it means the voltage can be decreased. Very important to know the definition of AC. It means that the direction of the current flows in the circuit is constantly reversed back and forth. So now let's talk about stepping up and stepping down transformers. Okay, so remember we said that when electricity is generated from a power station, this is the power station, and the electricity goes to the transformer, then the transmission lines. Okay, so we have a step-up transformer here, as you can see. Okay, which means that the voltage is increased. Then we come to the transformer lines and we decrease the voltage now, because this is a step down transformer before it goes down to our transmission lines that goes to our houses and also the factories. So from this transformer again to the houses, then we step it down again. But if we go to the factories, we also step it down again. So let's look at the step down and step up transformer now in details. A step up transformer has a voltage output greater than its primary voltage input. Okay, so the output is greater than the input, that is the step up transformer. So obviously, because we step it up, we increase it, so the output is greater and the input is smaller. This kind of a transformer steps up the voltage applied to it. For example, a step-up transformer is needed for a 220 volt appliance in a country with a 110 volt main supplies to be able to use it. Okay, so they say again, a step-up transformer is needed for a 220 volt appliance in a country with a 110 volt mains supply to be able to use it. A step-down transformer is the opposite and is used to power. For example, a 110 volt appliance in a country with a 220 volt mains supply. So we are going down. Okay, now let's talk about the national grid. You will understand what is the national grid. They say power stations and major substations all over South Africa are connected by transmission lines and towers, which are electricity pylons. Those things that are like trusses, we call them electricity pylons, those ones. Okay, so these are the transformer lines, and also these ones, the T ones. So now let's go back quickly. These transmission lines and pylons carry electricity over long distances all over the country. This transmission network is called the national grid. Electricity is generated at power stations, which supplies the national grid. Initially, the electricity leaving the power station has a low voltage. But in order to travel long distances effectively, the voltage needs to be increased. So that is why we have step-up transformers. So right immediately after the power station. So if I can go back to that diagram again, let me see. Oh, and now on So you see electricity is leaving the power station is 25,000 volts, and it goes to a step-up transformer. Now it's 275 volts because it has been stepped up. Then it goes to the transmission lines. Okay, so I wish I could have this picture so that now and then we go and refer to it, but it's fine. I can go back to it whenever needed. Sorry about that. Sorry about that. Where are we? We are here. Now, step-up transformers are used to increase the voltages between 155,000 to 765,000 volts while keeping the current low. So the voltage can be increased, but still the current will be low. Transformers are used to step up or step down the voltage. High voltage helps to transmit electricity faster, safer, and more efficiently across the country. Okay, because we want the electricity to travel faster and safely at the same time. High voltage electricity is carried to the substations where a set of step down transformers lowers the voltage to the minimum of 11,000 volts for local distribution to the industry, offices, and our homes. So let us go back quickly and see our substations. So you see when electricity leaves the power station, we step it up so that it can move faster and safer in the transmission lines. When it gets to our substations, we step it down to 11,000 volt, then it can go to our factories and our houses. We can also step it down further because we step it down on the main substation, then it goes to the houses. But when it gets to the houses or residential area, we're gonna step it down again to be suitable for the houses. That is 220 volts. And for the factory, we step it down to 380 volts. Okay, so you see how electricity is generated in a power station and is transmitted on the transmission line. Okay, so now let's talk about electricity distribution. So that is section 27.3, distributing electric power across the country. The electric current we use in our homes is mainly alternating current, which we use to power, for example, our lights and appliances. The other type of electric current we use daily to a lesser extent is direct current, which allows us to recharge batteries. Electricity comes from power stations that are operated by the country's electricity supplier, ESCOM. The long, thick wires or cables you see stretching across the countryside carry alternating current from the power station to transformers that distribute it to our homes and businesses. The current direction switches back and forth 50 times per seconds. That is 50 hertz. Okay, remember that is the alternating current. It can switch back and forth. Okay, so that is why we say it is the alternating current. So now let's look at lesson number 28 that covers electrical circuits and control. It will be a little bit of a revision. I'm sorry with the lighting there. Okay, so we say here an electrical circuit provides the path for electric current to flow. Okay, you must know the definition for electrical circuit. An electrical circuit provides the path for electric current to flow and must have a source of energy. This can be either a series circuit or a parallel circuit. In both circuits, you need one or more cells, resistors, lamps, switches, and electrical conducting wires. By that, we know that. And then let's talk about the series circuit. The resistors in a series circuit are connected in a row, one after another. So it can be the light bulbs here. You see all the resistors, whatever resistor you use. So they are connected in a row. This means that the current can only flow in one path because there is one path. The current flowing through each resistor is the same. The total resistance can be calculated by adding up the value of every individual resistor. The total resistance of resistors connected in series is the sum of their individual resistance values. It can be calculated as follows. So total resistance, which is RT, is equals to R1, R2, R3. We know that the resistance is measured in ohms. We have covered it at the in one of the previous lessons. So this is how we calculate total resistance in series circuit. Okay, now let's look at the parallel circuit. At the parallel circuit, the resistors in a parallel circuit are connected with the same terminals against one another. Okay, the current in a parallel circuit is divided through each current branch. So let's look at I will minimize this a bit so that we can see the entire information. So they say the current in the parallel circuit is divided through each parallel branch. So this is a branch number 1, branch number 2, and branch number 3. So resistance is not the same, but is divided through each branch. The voltage over each resistor in the branches is the same. However, the voltage is the same. The total resistance of the resistors connected in parallel is the reciprocal. Okay, reciprocal, it means 1 over something. Reciprocal of the sum of the reciprocals of the individual resistors. It can be calculated as follows. So this is the formula to calculate the total resistance of the parallel circuit. Remember, resistance is measured in ohms. We use the reciprocal. Okay, in this case, the current supplied by the battery is divided and the current over each resistor is determined by the value of the resistor. The higher the resistance, the lower the current. You remember we said current and resistance are opposite. The higher the resistance, the lower the current. The higher the current, the lower the resistance. We come to the new concept, which is Ohm's law. Okay, so you need to know what does Ohm's law state in weights. Okay, so which means you must be able to know this law of by heart. Okay, so let's go for it. Ohm's law, remember ohms is how we measure resistance. Ohm is the unit for resistance. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference, which is the voltage across the 2 points. The constant of the proportionality is the resistance. Okay, so you have to know this law as it says. Ohm's law states that the current through a conductor between the 2 points is directly proportional to the potential difference across the 2 points. The constant of the proportionality is the resistance. So we have the potential difference, which is the voltage. Now you get to know that the voltage is also called the potential difference. That's the symbol. And R is for the resistance and I is for current. The voltage is measured in volts. The current is measured in amperes, and the resistance is measured in ohms. So knowing this triangle, like what we did when we were doing speed, you must be able to calculate. If you have to calculate voltage, your high voltage, you know voltage is equals to current times resistance. And if you have to calculate a current, you hide the current, and current is equals to voltage over resistance. And if you have to calculate resistance, resistance is equals to voltage over current. You know how we use the triangle. Okay. And now we come to the new concept. Ohm's law is a new concept. You have to know what it states in words, and you have to know how to use this triangle to calculate either voltage, resistance, or current. And you have to know the units for each, for voltage, for amperes, and for the units for voltage, which is V, and the units for current, which is amperes, A, and the units for resistance, which is ohms. And you have to know that voltage can also be called potential difference. Okay, so now let's look at the new concept now, which is logic gates. This is new to you, but it's not that new. You will see if you know parallel bulbs connected in series and bulbs connected in parallel, it would be easy to understand the logic gates. A logic gate is a decision-making electronic component that has two or more input signals, but only one output signal. Okay, so logic gates use transistors to act as switches, okay, in electronic circuits. Remember, transistors are, we said when we know the electric components, we have to know if they are input, process, or control devices or output devices. So transistors are process devices, if I'm not mistaken. But you can go to the table and check. A closed or on switch. Remember, if the switch is closed, it is on, has a value of 1. So if a switch is closed, it is 1. And an open or off switch has the value of 0. The output of the circuit can either be 1 or 0. Don't worry, I will show you what do we mean by the ones and the zeros. Okay, so what we need to know for now is that if the circuit, if the switch is open, it is 0. Okay, and if the switch is closed, it is 1. Okay, so now we have different types of gates. We have the AND gate, and when you think of the AND gate, think of the light bulbs connected uh, in series. Okay, so the switches of an AND logic gate are connected in series as well. You see switch number 1, switch number 2. That is our input. The switches are our input in this case. For example, is closed for input. Okay, is equals to 1. We know that if the switch is closed, it is 1 because it is on. And if the switch is open, it is 0. Okay, because it is off. Off is 0, on is 1. Close is 1, open is 0. The output would be 0. This is because no current will flow to complete the circuit. Similar, there will be no current flowing if switch A is open and B is closed. Remember, we said the bulbs connected in series, if they've got only one path. So similar to the switches connected in series, they've got one path. So if you cut one, the other one will be off. So if this switch is open, this one is closed, and no electricity will flow. And if this one is closed, this one is open, no electricity will flow. Okay, you cut one path, the total circuit does not work. Okay, so now remember, now the output is this one and the inputs are 2 on the gate. So if this is 0, which means it is off, and this is 0, this will also be 0 because there will be no light in the bulb. And if this is 0 is open, this is 1 is closed, still there will be no. For us to have 1 here, or this bulb switching on, it means this gate must be closed, this switch must be closed, and that switch must be closed as well. Okay, so that is the AND gate. So both switches A and B must be closed for the current to flow, for the output to be. Okay, an example of an AND gate is the magnets on the windows and the doors that are connected to the alarm system of a house. All the doors and windows must be closed to complete the circuit. So the alarm system in our house uses the AND gate. So if you think of the AND gate, it's two switches in series and a light bulb. The input are the switches, two switches, and the output is the bulb. Okay. Now the truth table about the AND logic conditions. Don't worry, you'll understand this now. The truth table is a way to find out how the switches in the circuit must be connected for circuit to function. And A is 0, which means it's off in the last column and will mean that the circuit will not function, while a 1 will indicate that it will function. So this is the output, these two are the inputs. And for the AND gate, we know both the inputs must be on, so they must be 1. So if it's off, it means it's 0, it's 0, then we will get 0 here. So if 1 is off, it's 0, and 1 is on, it's 1, we will still get 0, because for AND gate we need 2 to be on. 1 is on, 1 is off, the output will be 0. But if the 2 are on, 1, 1, then this one will be on as well, will be 1. Remember, 1 means on and 0 means off. Okay, so you can even substitute this with numbers. So for off, you can say 0, 0, and you get 0. Here you can get 0 and 1, you get 0. Here 1 and 0, you get 0. And 1 and 1, it means the two switches are on. Then we get 1. That is for the AND table. Now we have the OR gate. That is for the AND gate. Now we go and learn about the other gate, the second one, which is the OR gate. And think of the switches connected in parallel now. All gates operate differently for AND gates. There are two switches or logic gates that are connected in parallel. And OR or logic gate condition is when one switch or the other switch is used to switch on the device. For example, smoke sensors and alarm panic buttons. The alarm will be activated as soon as one of the two detects an input. So one of the two has to work. So the switches connected in parallel, they have two paths. So if this one is closed, the current can flow because the current will use this path, even if this one is open. If this one is closed and this one is open, the current will use this second path, okay, to flow. And if both of them are closed, the current will flow in both paths. And if the two of them are off, then that is the only time that we will not have the bulb switching on. Okay, so if 2 is not working in a OR gate, then we will have the bulb off. Okay, so there's only way to have off is if the 2 is 0. So you see, if the two are off, so if we have 0, 0, then we'll get 0. But if any one is on, like here, 1 is on, we'll get 1. And here 1 is on, we'll get 1. And here 2 is on, we'll get 1. So that's the difference between the OR gate and the AND gate. Okay, so please try to read and understand these tables practically, but think of the series connection, one path, and the parallel connection, two paths. Okay, so in the AND gate, there's only one way we can have one, which is when we have two ons. Okay, so we have triple one. Anything else will give us 0 on the AND gate. But on the OR gate, as long as we have one on, okay, or both two on, then we will have a output that is working. Okay, so this is what we have. As I've explained, for the O, you just need one on. If you have one on, you will get on the output as well, which means you'll get one. And then on the AND gate, you need both of the switches to be on to get a 1. Okay, and this brings us to the end of our, what do you call it? It brings us to the end of our term 4 technology. Okay, we have covered everything that we need for term 4, and actually it brings us to the end of our technology work for the year. Okay, all right, thank you.